Hi, welcome back to my channel. This is a video that's kind of been kicking around in my head for a while, and I think I finally have a way of doing this. I'm going to try to balance this with some lighthearted criticism that's a bit tongue-in-cheek with actually some pretty serious topics, because um, this question came up to me because I was always thinking about the opposite. I was always been interested in trying to help people be better at programming. A lot of my research was done on using other abstractions to make average programmers more productive. And I want to kind of say I really was focused on average programmers in general because I kind of knew that basically there was a set of people that were going to be good no matter what tools that they used. And it was for me not as an interesting of a problem to make even more tools for those type of people versus making tools that really solved the average case, basically the day-to-day work that programmers are doing. And and I was thinking about that. Part of it was like, well, why are people bad at coding? And why are people bad at coding now versus when I first started looking at those questions 20 years ago? And I realized, of course, I need to revisit that because the assumptions I was making about how people program and what technologies that they use is going to be completely different. So I did a little bit of research around that, and I decided, you know what, I'm going to do this. It'll be a fun little rant. Hopefully, it'll attract some attention and maybe get some views. But it was kind of fun to write, and so I thought I'll just go ahead and go for it. So first of all, it's just too easy to pick on TypeScript, to be perfectly honest. And the reason I do point it out is because one of the things about it is that because how often it is used in today's, by today's programmers, makes it a natural target to look at. If a lot of people are using this tool and this is where they're having a lot of problems, then this is where I should point some criticism at. Now, that being said, are even worse are the people that have insisted that TypeScript doesn't provide any value to them, and you're better off just using plain JavaScript. Who needs things like types and you know assistance to figure out what this random variable does in terms of what can you call on it, you know, that kind of thing. And you see that from a few people, and some of them are basically good enough programmers that they can get away with anything. But it's okay for people to want to have typing. Dynamic typing sounds really great until you realize that in practice, from the day-to-day standpoint, it's actually really tricky. And you have to do a lot of things to make sure that you keep things nice and clean in that regard. And some of us, like myself, are just happy to have a type checker when you need it. The thing about it is the JavaScript tools and the TypeScript tools, the frameworks on the web client side, on the server side, wherever, the various runtimes. So, the browser runtime versus Node versus Bun versus, there's four different ways. I mean, like I said, there's an explosion of tools around there. Um, are all filled with these quirks and limitations. And it's signs of how this whole ecosystem evolved. And I mean evolved and not designed. And one of the things that's really interesting for me about the JavaScript thing is that they started out in the traditional way of designing programming languages, was basically through standards committees and all types of stuff, moving into a more individualized process per language that's basically based on more organic kind of processes and more informal types of interactions. And that overall, that transition was managed fairly poorly. In my mind, there's been a lot of basically when they moved to that more informal model, there was less people that were backing up the language by providing, guidance about how to really do things and trying to put their foot in the ground. And it just kind of seemed to have slowed down in terms of trying to solve some fundamental problems. Whereas other languages like Java and C Sharp, who also started out in that, oh, we want to formalize things and we want to write big standards and put them, big standards documents and stuff like that. When they moved to the more organic types of processes, they seem to fare a little bit better. Java is a little bit more formalized, and so maybe that's why some of the progress was slower. C Sharp, I think, was does very well because they've kind of oriented their whole thing around, okay, we're going to use GitHub to do this, when they decided open source.net and make it cross-platform, they really set up a lot of ways to like, okay, here's how we're going to establish how we do new releases of the runtime, and here's how we decide we're going to do new versions of the language. We're going to decouple them. We're going to do all these types of things. We're going to bring in more community feedback, but also we're going to be a benevolent dictator by providing plenty of resources in terms of money and people to make sure that the kind of built-up expertise about the language isn't lost. So some of the people that worked on that language are still working on that language and are working to transition that knowledge to the next generation of programmers. In JavaScript, there really wasn't that transition or handoff. And not only that, but some of the people that were really advocates of the language have kind of turned on it and have basically said that, it really is just fundamentally not that great of a thing. And there is a demand for something better. And Douglas Crawford, the person that wrote the JavaScript, the good parts, which kind of pointed out this core little language out there that could be very useful in this kind of overwhelming larger language, has pretty much said that it's time to move on, and that there's much better stuff out there to use inside browsers as well as on the server side. So on top of this, TypeScript wanted to tame this stuff and make it a little bit more approachable for developers in terms of like doing things like, basically it started out to be like, we kind of want autocomplete. Can we have autocomplete and some type checking? And they did some very interesting things around that. And Anders Heisberg and Mats Torgensen did some pretty interesting stuff there. What has happened though is that the overall type system, in this effort to try to capture how JavaScript does things idiomatically, has turned into what is this basically very ad hoc, not at all designed, dependent type system, which in too many cases is complex enough that it can turn those very simple autocompletes that you wanted to do, that will grind your computer into dust now. There's literally cases, and some people have brought out, they put in some caching to try to fix this. It's the TypeScript tools themselves are having to be ported to another language entirely to get better performance, because they just can't do it with TypeScript. They can't bootstrap anymore. And it was literally one of the things where it's like, if you go into Visual Studio Code and stuff like that, it was one of those things where I remember that when Visual Studio Code, excuse me, I remember when IntelliSense kind of first came out, when there's this idea of, ooh, this is new kind of autocomplete in this IDE environment. And it's kind of an extension on C tags and E tags, but it works better because it's kind of like, it's this little pop-up and you just click things. We've got a UI experience. This is 2007 and all that kind of stuff. It worked better than sometimes what VS Code and TypeScript LSP do. There's just going to be more lag, and not only that, but those tools crash more than they did back then. And it wasn't like those tools were incredibly stable to begin with, but they were more usable. And I bring this up because the overall development environment is really hostile to developers in terms of just getting code out there. But it's tolerated because what else can you do? There's no other options. You have to do some of this. And that's just the development experience. The debugging experience is a nightmare. It just is a nightmare. It's one of those things where it's like, it's almost impossible for people like me who are used to doing stuff in the back end with IDEs like Visual Studio or IntelliJ to go back into this environment, because it just seems impossible to do anything versus just trying to write the program the right way and then just pepper it with printf statements and that just hope that you can find something that is obvious and learn how to fix it. It seems to be impossible to provide a structured debugging process in that environment, and that really just fundamentally affects how effective you can be as a programmer. So how do you get better if you're dealing with this? I would say that you can, if you accept that it will be bad, do your best to deal with it. And not only, don't accept it. Don't let anybody say, oh, this is always going to be this way. This is the best it's going to be. And anybody who tells you otherwise really doesn't understand it for these reasons. Yeah, if you don't accept that, then your skills will not backslide. And you can be a good enough coder until something better comes along down the road, and not get mired so much in the day-to-day of how the tools work and all those inconsistencies. You have to just be able to keep your eye on the ball there. Otherwise, you will get stuck in the mud, and it won't be a very pleasant place to be. Reason two, This has come up a lot recently, and it's kind of an interesting building. There's more consensus people building around it, which is basically you think object-oriented programming is bad, and I'll let you slide if you think it's misused. But there's really a lot of people out there. What they're really saying is like, no, this is bad. This is a mistake. And we're going to take all this stuff and we're going to do better. That's good. It's never a bad idea to look at some of those things. But even worse is the people that go on and say, because obviously functional programming is inherently better. Now, here's the thing. If you aren't aware of some of the other videos on my channel, I have a whole series on the Racket programming language, which was based on Scheme, which itself was a variant of Lisp, which is one of the first functional programming languages, as well as being one of the first functional languages as well. And I really like functional programming. And I personally would be really much more happy in a world where F sharp was the most common language, or Haskell was way more common than Java, and so on and so forth. I would be happier in that type of thing. That being said, I would also have to admit that, to be perfectly honest, there might be a lot less people doing programming. Also, it's tempting to, instead of just pointing at the people that are like, oh, but functional programming is obviously better, because a part of me really wants to agree with them, but to say it's like, oh, well, the worst is the people that think object-oriented programming is always good. The problem is that when I really look at this, we all kind of know the pitfalls here. We all kind of know how the enterprise code looks and all that kind of stuff, and that it's very verbose. There's all sorts of like this abstractions everywhere, all these patterns. The thing about it is that as tedious as it is, you can wade through those code bases. It's slow, it's arduous, but it's predictable, and it's not it's not neat, it's not elegant, it's not clever, but it works. And for people that just want to do the day-to-day type of stuff, it can be a little bit of a drag, but it works. What it doesn't happen is that it's death sometimes is even better than trying to be more clever and more elegant. And I think there's a lot of traps that people fall into is that they mistake of like, oh, well, wait, I don't want to do all this verbose stuff to doing as little as possible is therefore better. And what it means is that if you're discounting OOP, you're just throwing out a whole set of language features and a means of reasoning about programs that really can be useful and have proven themselves to be worth in plenty of domains throughout the history of things so far. You know, the explosion in desktop GUI programs that ultimately created the demand for mobile and web applications really came out of C++ being efficient enough to do things, but also allowing things like data abstraction and inheritance to be useful enough that people could actually go off and make things by extending these libraries versus doing them like they used to do before with like raw X11 or the raw Windows API. It was actually much easier to do, and what meant more people could actually do it, and therefore more of that software got developed. Now, I'm going to admit all this solid stuff is a pain, and if you don't know what solid is, then maybe you're better off for it. But the thing about it is, everything they're talking about there is something that you have to deal with at some point. The thing is that what people do is that they, again, it's when people whack them over their head, where it's basically, it's an end goal. Your code will be completely solid versus is it solid enough? Then yes, that can be a pain. Now, some people will ask, it's like, well, isn't this going to just be as archaic as COBOL was back in the day? Or, excuse me, not as COBOL was back in the day, but COBOL is now? Well, that's certainly possible. Now, that being said, and I think the analogy there is interesting because it kind of presumes that a lot of that code, that, like Java, is going to be the next COBOL. Also, kind of presumes, and maybe rightfully so, that there's going to be a lot of Java code running in a lot of places for a very, very long time. And I think that is certainly true. And so someday it might be that where you're having to bring people out of retirement just so they could change some old Java programs. But that's not today, and that's not happening every time, anytime soon. And it's kind of ignoring where object-oriented programming languages are also going in terms of adopting other features as well. All right, going back to functional programming. Okay, again, avowed functional programmer, would love to be doing more functional programming, would have loved to do it in my career, and I've studied a lot of it. I was lucky to do so with people that are very, very skilled in it. Um, but looking at that, I have to say, in general, it's just harder to become proficient in functional programming to the level that is necessary to get most of the programming work that people need to do day to day. Here's the interesting aside. That doesn't mean I don't think that teaching functional programming and Racket first isn't the way to go in terms of education. That seems a little bit contradictory, but the thing about it is I think it is much easier to introduce people to the immutable environment by default environment with functional programs, get them used to higher order functions and stuff like that, and then introduce mutability and things like ordering and mutable data structures and stuff like that on top of that foundation, so that you know what changed moving forward. And the reason being is that that functional programming environment, especially in Racket, distills what a programming language is down to its essence, and it becomes kind of like this core language or core sets of concepts that'll help you learn any other language going down the road much easier than if you have not been exposed to those core things from the very beginning and at the beginning. And that's the important thing is you go in and saying, hey, you may have done some coding before, but we're going to start you on this more, basically theoretical foundation that's really going to help you learn multiple things in the future. And you can really, that's going to be a better foundation. So I certainly think that, the first 2 years of, programming in terms of the 4-year degree should be mainly oriented around a Racket. And then also setting up some people with ideas of how they want to specialize and what they want to learn in the next 2 years and what programmers they want to become and what kind of languages they really want to use as they go out and join the working force. Okay. As another aside, there are a few people, and maybe one of them will watch this video. I kind of doubt it, but I'll mention this anyway. If you've only used JavaScript or TypeScript and are really passionate about functional programming, you probably really don't understand all the trade-offs that really go into it because JavaScript and TypeScript are really, really loosey-goosey when it comes to functional programming. And that's not necessarily a bad thing. Strict FP or pure functional programming languages are hard to use. And the thing about it is that the lines get more blurry in modern languages to begin with. Like I said, I can't say that you can take a look at things like Rust, and say that it isn't adopting some object-oriented features as well as some functional programming features in an interesting way. C# definitely is a complete hybrid language with object-oriented features and functional programming features. And Java is going the same route as well. So unfortunately, to really kind of understand functional programming from a pure standpoint, you probably need to have some experience with actually, like I said, either like Racket or Haskell or F# is another great option as well. And again, how to get better is a few things. One is that I can tell there's a lot of people that are commenting about how all this object oriented stuff sucks and they never have read the domain design driven book and that introduces all the stuff that they lament. They may have looked at the design patterns book. I let them off the hook if they haven't read it because it is old enough that a lot of the patterns there don't really actually apply anymore. It was targeted when C++ was fairly new, and a lot of the things it does are done completely different in languages like Java or C sharp. Even though some people don't know that and they're still using design patterns that are in the book when they don't need to. But if you haven't read the domain design book, you should read it, the actual source itself, and you can do it in a critical way. But the book itself does a way better explanation of why they are orienting these things and what kind of problems they're trying to solve. And it's much more honest about its limitations and the overhead that required to do that things stuff this way, and more so than some other books in the vein, to be perfectly honest. So it's 20 years old. It still holds up, and I don't think it's going to need a replacement for a bit. I think it will probably be overdue. It will be a little bit overdue for overhaul given modern languages like C Sharp and modern Java, but not, it's still, most of it is fairly useful and applicable. Now, if you know Java and stuff like that, and if you've done some object-oriented programming, get outside your comfort zone and learn like C Sharp or vice versa. Or like I said, if you're on the .NET gang, you have two choices. Take a look at what Kotlin's doing. Again, that's going to make you can do Android projects on the side easier because of that. Or look at what modern Java does and just kind of see how they're borrowing from each other and some of the interesting differences there. And if you really want to do more about functional programming, then do some racket programming, or you can really do Haskell for some bonus points. Or if you're a .NET person, or you really want to actually work with a really fascinating language that has to kind of balance pure functional programming with running on a .NET runtime and being able to access those libraries, F Sharp's really great. Like I said, I would have loved F Sharp to to be the primary default language for doing programs, but there's a very good reason it wasn't. Anyway, that's part one of this presentation. If you like this video, please like and subscribe to let YouTube know that I actually do exist as a human being. Thanks for watching, and I will see you in the next video.